On this 2019 to 2024 Ram 1500DT with the 5.7 gas engine, P0172 means the PCM is seeing fuel system 1/1 rich. In plain terms, the fuel control correction may be pulled down because that bank is being interpreted as too rich. The truck may turn the MIL on, and if it is stop/start, that system can be disabled while the code is active. As a general diagnostic direction, this can come from possible fuel delivery problems, fuel quality, a leaking injector, purge flow when it should be sealed, air or exhaust restrictions, engine mechanical issues, MAP input, upstream oxygen sensor wiring, the sensor itself, or in the end, the PCM. Start with the basic system checks, then follow a structured diagnostic approach instead of jumping straight to a sensor. Before testing, make sure you are working under conditions where the monitor can actually run. The monitor is gated with the engine running in closed-loop fuel control, battery voltage above 11.0 volts, barometric pressure greater than 75 kPa, ambient temperature above -7 degrees C, 20 degrees F, fuel level greater than 12%, and altitude below 2,590 8m 8,500 ft. The failure logic is based on the sum of short-term and long-term fuel correction dropping below a calibrated threshold, generally 67%, with 100% considered nominal. After 30 seconds of fail time, the diagnostic fails. The rich condition is tied to an emissions threshold of 1.5 times. First, use the scan tool to read codes in all ECUs and record what is stored. Save the vehicle scan report and the related recorded data so you have the conditions that were present when the fault set. Clear all DTCs, turn the ignition off for a minimum of 10.0 seconds, then turn the ignition back on. Reproduce the operating conditions that set the code, using the captured data and the monitor conditions, then read the codes again. If P0172 comes right back, continue with the diagnostic path. If it does not return, treat it as an intermittent condition and do not force a repair without more direction from the symptoms or data. Next, look at the recorded codes. Even though an oxygen sensor or its wiring can set this fault, this rich code is more likely to be driven by a mechanical, fuel, or air handling problem. If the vehicle has drivability or fuel system issues, or if any active or pending fuel or air handling codes are present, diagnose and repair those concerns first. If there are no related active or pending faults, move on to the exhaust check. Now check the exhaust system for restriction. Start the engine and verify good exhaust flow at the tailpipe, then visually inspect the exhaust for damage that could restrict flow. If you find a problem, make the appropriate repair and verify the repair. If the exhaust checks out, check MAP sensor operation using the MAP sensor operation test. If that test finds a problem, repair as needed and verify the repair. If the MAP operation checks good, continue to the purge solenoid test. For the purge solenoid, turn the ignition off and disconnect the hoses at the solenoid. Apply 5.0 in Hg of vacuum to the engine side of the purge solenoid with a hand vacuum pump. The solenoid should hold vacuum for a minimum of 15 seconds. If it holds, reconnect the vacuum hoses before continuing and move to the fuel delivery test. If it does not hold, verify good pin-to-terminal contact at the evap purge solenoid and PCM connectors. If the connector contact checks good, replace the purge solenoid, then verify the repair. After that path, or if the purge solenoid passed, check the fuel delivery system using the fuel delivery test procedure. If a fuel delivery problem is found, repair it and verify the repair. If not, continue to engine mechanical checks. At this point, look for mechanical or fuel-related causes that can make the PCM correct rich. The air induction system must be free of restrictions. Valve timing and engine compression must be within specification. Fuel must be free of contamination. If a leaking injector or abnormal spray pattern is suspected, remove the fuel rail with the injectors intact. Energize the fuel pump to maintain rail pressure, and check for fuel leakage before the suspect injector is actuated. Then actuate the suspect injector or injectors with the scan tool, inspect the spray pattern for abnormalities, and compare it with the others. If you find an engine mechanical or injector-related problem, repair as needed and verify the repair. If no mechanical problem is found, move into upstream oxygen sensor wiring checks. Before testing the oxygen sensor circuits, remember the caution here. Do not probe the PCM harness connectors. Probing those connectors can damage the PCM terminals and create a poor terminal-to-pin connection. Use the GPEC diagnostic adapter 10436 for this diagnosis. Disconnect the upstream oxygen sensor harness connector and the PCM-C2 harness connector. Connect the adapter and check the upstream oxygen sensor circuits for a short to ground and for an open or high resistance between the oxygen sensor connector and the PCM-C2 connector. If wiring problems are found, repair them and verify the repair. If the wiring checks good, continue to the upstream oxygen sensor step. If the earlier checks did not find the cause, replace the upstream oxygen sensor. Then reconnect the bank 1 upstream oxygen sensor and PCM harness connectors. Turn the ignition on, clear the DTCs with the scan tool, and operate the vehicle under the captured conditions or the monitor conditions that set the fault. If P0172 does not return, the upstream oxygen sensor repaired the fault, and you still finish by verifying the repair. If P0172 does return, continue to the connection checks. Now perform any applicable service bulletins, then inspect the PCM and related connections. Disconnect all PCM harness connectors, any related inline harness connections if equipped, and the related component connectors. Inspect connector installation, connector locks, corrosion, water intrusion, weather seals, bent terminals, overheated or discolored terminals, terminals pushed back in the cavity, spread terminals and terminal tension. Repair any conditions found. Reconnect the PCM connectors, inline connectors and related component connectors, making sure everything is fully seated and locked. Clear the DTCs, test drive or operate the vehicle under the monitor conditions and read the codes again. If P0172 does not return, the wiring or poor connection problem has been repaired. If it does return after this connection inspection path, replace and program the PCM, then verify the repair. Keep verification separate from the category-specific testing. Anytime you repair a found fault, clear the code, operate the vehicle under the proper conditions, and confirm P0172 stays gone. The big takeaway is to prove the rich condition path in order. Confirm the code, handle other fuel or air faults first, check restrictions, purge, fuel delivery, mechanical condition, injector behavior, oxygen sensor wiring, then the sensor and final connection checks. For more diagnostic training, visit stepdiagnostics.com.